All right, this is the last lesson of Chapter 8. So today in 8.6, we are going to be looking at solving rational equations. All of our work up until this point has been dealing with expressions, which means there was not an equal sign. We were not worried about solving for x. We were just simplifying those expressions, multiplying, dividing, adding, subtracting. Today we are solving rational equations. So we are actually solving for x. We're trying to find the value of x that makes the equation true. So as a little introduction here, I have some tips, some things that we're going to talk about in the process as we start to move into some of our examples. So first thing we need to define that we're going to be talking about a lot today is called the least common denominator, or the LCD. It is the smallest number or expression containing all the factors of the original denominators. So we are going to use the LCD in the context of solving rational equations so that we can cancel everything from every denominator. Also, when we're solving rational equations, we're going to be sure to check for extraneous solutions, which are solutions that result from doing the algebra of the problem, but they do not actually make the equation true. In this case, we're going to need to exclude any solution that ends up causing our denominator to be 0. So it's just like when we thought about those values that were restrictions when we were dealing with our expressions. We never want our denominator to be 0. All right, so we're going to start off with a really simple example. So notice how this is an equation. We have an equal sign, and it's a rational equation because we have what looks like fractions that we're dealing with on both sides. So we're always going to start down here by determining that LCD, the least common denominator. So that's going to be the smallest number. In this case, it contains all the factors of the original denominators. So going one at a time, this first denominator, we're not going to include 1 since 1 is a factor of everything. So really that first denominator, we're just going to put a 5 here to represent that factor. And then in the second denominator, we have a 2. Now we're going to multiply that by the 5. And looking at the last denominator, we have a 10, but inside of the 10 contains the factors 5 times 2, which the 5 and the 2 are already represented down here in the LCD. So the way that I like to think about this LCD is, like in this case, what is the most number of 5s that occur in a single denominator? Well, the first denominator only has 1 5. The last denominator also only has 1 5. Let me make that a little bit bigger. So our LCD is just going to have 1 5. Sometimes a common mistake is that students will list out 5 twice. They'll think, oh, 5 times 5, but no, we're only listing it once. We'll ask the same question about the 2. So what is the most number of 2's that occur in a single denominator? This denominator only has 1 2. The other side only has 1 2, so we only have 1 2 in the LCD. Now 5 times 2 is 10, but for the purpose of what I'm going to show you that's going to help to extend to other examples, I'm going to have us keep it separate as 5 times 2. So what we're going to do with that LCD is we're going to multiply everything on both sides by the LCD. And we can do that because this is an equation, and as long as we do the same thing to the left side that we do to the right side, it's going to maintain the equality of the equation. Now, what we actually have to think about on the left side, we actually have to distribute that to both parts because we have a plus sign here. And so right below, the way that I'd actually like you to write it out is to show the 5 times 2 multiplied by the first fraction, 4x over 5, plus 5 times 2 multiplied by the second fraction equals, the other side just stays the same. Now, by the way, that 5 times 2 that we're multiplying both sides by, it's really 5 times 2 over 1. So I want you to see that the 5 and the 2 are really on the numerator. And that's going to allow us to cancel common factors that will get all of our original denominators canceled. So in the first piece, notice how we have this 5 on the numerator, And over here we have this 5 down in the denominator, and so we can cancel. We are left with 2 times 4x, which is 8x. Let's go ahead and bring down the plus sign. In the next part, we have this 2 on the numerator. Over here we have a 2 in the denominator, so let's go ahead and cancel the common factor of 2's. We're left with 5 times 3, which is 15. Now, on the other side, the 5 times 2 is really 10, which will cancel out with the 10 there on the denominator, leaving us with just 3x on the numerator. So we've accomplished our goal with that LCD. We were able to cancel all of the original denominators. Now it's going to turn it into a nice simple equation that we can continue solving for x. Let's get all the x's on one side, so that's negative 5x. The regular number is on the other side. Now we can divide both sides by negative 5, and we end up getting our final answer, x is equal to negative 3. All right, so here's another example now where we actually have an x in a couple of our denominators. So in this case, if we think about the restriction right at the very start, x cannot be 0. So if for some reason we're going through the process of solving and we do the algebra and we end up getting that x is 0, that would be extraneous. That's the only value of x that would be not allowed for this particular situation. So thinking about the LCD, again, at the very start, looking at the very first denominator, the factor that we can put into the LCD from that is an x. Looking at the second denominator, we have a 3 times x. Well, we already have an x represented here, so we do not need to list it twice, but we do want to represent the 3. Make sure that those are being multiplied. In the last denominator, we just have a single 3, which is already represented in the LCD. So our LCD this time, x times 3, or we can write it as 3x. So we are going to think about multiplying both sides of our equation by 3x. And just as we did before, we are going to have to distribute on the left side because we have a subtraction sign. So that 3x is going to multiply by each part. So expanding it out to show that, I'm going to show 3 times x multiplied by this first fraction, 3 over x. Notice how I am using parentheses here to show the separation of the parts. Bring down the minus sign. That 3 times x is going to multiply by the second fraction. And then the right-hand side will stay the same. That 3 times x that we're multiplying everything by is really like 3 times x over 1. All right, so let's go back to the beginning. So here's where the fun begins. You guys are like, this isn't fun. No, it is. Just wait. We have an x on the top and an x on the bottom. How cool. They can cancel. So we're left with 3 times 3, which is 9. Bring down the minus sign. Oh, I love this next one because both the 3 and the x from the top can cancel with both the 3 and the x on the bottom. Now, here's what's a little tricky. We're left with x plus 21. Keep it in parentheses. Why, you ask? Well, there's a subtraction sign out in front, and we know whenever we're subtracting a quantity, we're subtracting both parts. It is going to distribute to both the x and the 21. On the other side, just the 3 on the top is going to cancel with the 3 on the bottom, leaving us with 5 times x. Now, we got rid of our denominators. We're ready to just solve the simple equation that we are left with. So we have 9 minus x minus 21. And let's do 9 minus 21, which is negative 12. At the same time, I'm going to think about adding x to both sides to move it over, so that ends up equaling 6x. We'll divide both sides by 6. And negative 12 divided by 6 ends up being negative 2. It's not extraneous, only if it were to equal 0. So that's okay. It doesn't make our denominator 0. That's just our final answer. Now, as we continue, we're going to find our denominators get a little bit more complex. So let's take a look at this next problem. We've got this nice x minus 3 at the beginning. We've got an x plus 3 at the end. If you are able to factor a denominator, we need to factor it in order to figure out the LCD. So this x squared minus 9 really factors into x plus 3, x minus 3. Now we're going to move forward. We're going to think about this exactly the same way that we've done the others. So in this first denominator, we have the factor x minus 3. We're going to think of that as just one unit, one factor. We're going to put it in parentheses. Now, in the next denominator, we have x minus 3, which we already have represented in the LCD. The other factor that we need to represent in parentheses is x plus 3. And then for the last one over there, we have an x plus 3, but we already have that represented in the LCD. We do not need to list it twice. So sometimes the LCD looks like this. It's just a quantity in parentheses multiplied by something else in parentheses, which is totally fine. When we multiply both sides by the LCD, initially that will look like this. And on the left side, because of the plus sign right here, we are going to distribute that to both parts. I am going to write out this whole thing, so I'm going to kind of start on the far left so I have some space. So for the very first part, I've got x minus 3 times x plus 3, and that's going to multiply by 2x over x minus 3. So that was just the first fraction. I'm going to bring this plus sign down, and then do it again. So start with the LCD. I always like to list the LCD in front. Multiply that by the second fraction, 6 minus 2x. Now for the denominator part, you can write it as x squared minus 9. I'm going to write it in factored form just because it'll be easier. I think it'll be more straightforward in the next step of canceling. What cancels? Everything cancels there. And then the last side, we'll just write that out the same way. It's okay if you put your LCD on the right-hand side for this one, or you can write it in front, whatever you want to do. All right, so let's go back and to the beginning. For the very first part here, we are going to cancel x minus 3 with this denominator x minus 3. So notice how we have the quantity x plus 3 in parentheses. That's being multiplied by 2x. So that 2x is going to multiply by both the x plus 3. It's going to distribute to the inside. So that's going to make it 2x squared plus 6x. All right, let's look at the next part. Both pieces cancel. X minus 3 cancels, x plus 3 cancels. It's a plus sign, so we don't have to worry about distributing a negative. We're just going to bring down the numerator part there that's left, which is 6 minus 2x. And then on the other side, it's just x plus 3 that cancels. And for the leftovers, we have to distribute. This x is going to multiply by that x minus 3, so that's going to make that x squared minus 3x. Okay, so now we have a lot of simplifying to do here. We need to combine like terms. Let's look at that first. On the left side, we have positive 6x minus 2x, so that's going to be 4x. So let's rewrite this left side as 2x squared plus 4x plus 6. Now we're going to approach solving the rest of this one a little differently than the last ones because we have an x squared. The x squared means that it's quadratic. And the easiest way to solve a quadratic equation is to get everything on one side, set it equal to 0, factor it, set each factor equal to 0, and solve for x. So what I'm going to do here on this one, I'm going to subtract x squared from everything on both sides. At the same time, I'm going to add 3x to everything on both sides. And that's going to give us x squared plus 7x plus 6 is equal to 0. So now we have a really nice problem that we can factor. We're going to think, what multiplies to 6 and adds to 7? 1 and 6. So we'll factor this into x plus 1 times x plus 6. And then we are going to set each factor equal to 0 and solve for x. So we have x equals -1 and x equals -6. By the way, the restrictions on this problem from the very beginning, the values of x that would not be allowed, are just 3 and -3. We did not get either of those for a solution, so both of our solutions work. Neither are extraneous. All right, we have two more that we're going to take a look at. So this next one, thinking about our LCD, from the first denominator, we're going to take that first factor, put it in parentheses, x plus 5. And then from the second denominator, we've got an x plus 3. Now for this last denominator, notice how this factors into x plus 5 times x plus 3, where both of those factors are already represented in the LCD. So we are ready to go. We're going to multiply everything on both sides by the LCD. The LCD is going to have to distribute on the left side to both parts. So I'm going to write it out for each part. So we've got x plus 5 times x plus 3 multiplied by the first fraction, 1 over x plus 5. We're going to bring this addition sign down. Now we're going to do the LCD again. Multiply that by the second fraction. Okay, bring down the equal side. And we've got this -2 over, I'm going to write the denominator factored, and that'll multiply by the LCD as well. Okay, so let's go back to the beginning. So for the very first part here, the x plus 5s are going to cancel. We are left with x plus 3 times 1. Anything times 1 remains the same. So that's x plus 3. Bring down this plus sign. For the next part here, we are going to cancel the x plus 3 now, leaving us with 2 times the quantity x plus 5. We do need to distribute the 2, so that's going to become 2x plus 10. Bring down the equal sign. On the other side, the x plus 5s are going to cancel. The x plus 3s also cancel. I love that one. And we're just left with the numerator, which is -2. Hey, look, it's not quadratic. It doesn't involve an x squared. So all we need to do is get the x's together on one side and the numbers together on the other side. Let's first combine like terms on the left. So this is going to simplify down to 3x plus 13. Let's go ahead and just subtract 13 from both sides. And then we're going to divide everything on both sides by 3. So -15 divided by 3 is -5. Now, here's the interesting thing on this problem. Hang on just a second. So if x were really -5, and if we were to plug that in for x back into the original equation, in the very first fraction here and at the very last one, we have an x plus 5 in the denominator. Hold on. So if -5 were plugged in for x, -5 plus 5 is 0. That would cause the denominator to be 0, which is not allowed when we're dealing with a rational expression or a rational equation. And so this is an extraneous solution. It does not actually work because it makes the denominator 0. So instead, we're going to cross it out, and we're simply going to state no solution. All right, so in this last example, notice how the first denominator, we have an x plus 1, so we're going to put that into the LCD. The second denominator, we have an x minus 3, so we're going to put that in parentheses. Notice how we don't see anything on the other side. For the last denominator, it's really an invisible 1 there. So we don't need to add anything further to the LCD. It's just x plus 1 times x minus 3. So we're going to think about multiplying everything on both sides by the LCD. So for the very first part here, we've got x plus 1 times x minus 3. That's going to multiply by the first fraction. x minus 1 over x plus 1. Bring down the subtraction sign. We have the LCD again, multiplied by the second fraction. And then on the other side, we have 3, and then we'll just put the LCD right here behind it. All right, so going back to the very first part, notice how the x plus 1 on the top here is going to cancel with this x plus 1 on the bottom. The resulting pieces in the numerator here, we're going to multiply them together with FOIL. So we have x squared minus 1x minus 3x plus 3. That's going to turn into x squared minus 4x plus 3. Now we're going to bring down the subtraction sign before we start into the next part. Notice how the x minus 3 on top is going to cancel with the x minus 3 on the bottom, leaving us with 6 multiplied by the quantity x plus 1. The 6 is going to distribute to both parts. You also need to put the 6x plus 6, the result of distributing, needs to go inside parentheses because the subtraction sign in front is going to subtract both parts. So eventually it's going to be minus 6x minus 6. All right, now on the other side, we're going to FOIL the x plus 1 times x minus 3. We're going to take that result and multiply each part by the 3 that's in front. So for the initial FOIL, we have x squared minus 3x plus 1x minus 3. So that's x squared minus 2x minus 3. We're going to put that in parentheses, and the other 3 that was out in the very front is now going to distribute to all 3 parts. Okay, so that's going to end up being 3x squared minus 6x minus 9. I'm just going to move this equal sign over here so we can get things to fit. So rewriting the left-hand side, starting with x squared minus 4x plus 3, I'm going to go ahead and distribute that minus sign to make it minus 6x minus 6. Now we have a lot of simplifying to do. Let's combine like terms on the left side. So negative 4x minus 6x makes it negative 10x. Positive 3, negative 6 is negative 3. Now this one is quadratic because we have the x squared there. So we need to get everything on one side, get the other side set equal to 0 so that we can factor. And when we're factoring, it's easiest to keep the x squared term positive. So I'm going to move everything over to the right-hand side. So I'm going to start by subtracting x squared from both sides, adding 10x to both sides, and adding 3 to both sides. So that gives us 0 equals 2x squared plus 4x minus 6. Now before we move forward with factoring, we have to look for a GCF. In this case, all of those 3 terms can be divided out by 2. Rather than writing the 2 out in the very front with parentheses, this is an equation, and so we can actually divide both sides of our equation by 2. What's nice about this is that 0 divided by anything is 0. So we have 0 equals x squared plus 2x minus 3. So we have a really nice basic trinomial to factor. We're just going to do what multiplies to negative 3 and what adds to positive 2. So let's do positive 3 and negative 1. So in parentheses we have x plus 3. In the other parentheses we have x minus 1. We're going to set each factor equal to 0 and solve for x, giving us negative 3 and positive 1. Alright, so those are our 2 solutions. At the very beginning of the problem, the restrictions would have been that x cannot be positive 3 and x cannot be negative 1. But notice how our actual answer ends up being the opposite sign of that, and so our answers are okay. They are not extraneous. They will not make the original equation have a denominator of 0.